Okay, so now that we've set up a way that we can always reference the rotational chop data for our bone based solely on knowing our bone name, we can now turn around and actually set up our matching FK to IK. Now again, this was covered in a lot greater detail back in Technical Rigging 3. And basically, I'm going to show all of the code here again, but I'm not going to necessarily explain it in quite the same detail because this is stuff that we have covered before. And basically all we're going to do is reference that chop data down inside the chop network that deals with the rotations being driven by IK. We're going to reference that data and apply that to our FK controls. To do that, we need to know about a few things. We need to know about the IK data, so we need some reference to a chop down in our chop network. We need to know about our start bone, and we need to know about our end bone. It's also worth pointing out that we are going to assume that our FK controls are named in the default naming that the tool uses, and that is that they are named with our bone name underscore FK control. If you have renamed your FK controls, the code as we're about to create it isn't going to work. You're going to need to either rename your controls to match that naming convention or edit your script in order for the controls to be referenced correctly by the script. So with that, let's find our ARM FKIK controls asset, right click, come down to type properties, and on the type properties window I want to add a few new parameters. They're all going to be operator paths. The first is going to be our start bone, and that's going to be object bone only. The second is going to be our end bone. That also is going to be an object bone only. And then finally, we're going to have the ability to specify our kin solver, kinematic solver, and that's going to be any chop. So that's going to allow us to specify that null after we've renamed the chops data. We can then go ahead and reference that data. So I'm going to accept the type properties window, and let's get these pointing to the correct nodes in our network. So we want our upper arm exporting a relative path for our start bone. We want our lower arm for our end bone, and then we want our arm kinematics grab values for the kinematics solver. So with that in place, we can also go ahead and create a button that's going to call on our script we're about to write. So let's bring up the type properties. I'm going to create a button. Let's place this up with our other parameters, and I'm going to name this button match FK to IK. And this button's going to be responsible for calling on the script that we're about to write. So let's jump over to the scripts tab. We do need to create a Python module for our Python script to exist within, and I'm going to define a function called match FK to IK. And the first thing I want to do is go through and basically comment out the block of code that we're about to implement. So the first thing I want to do is get nodes from asset parameters. So we're going to get our start bone, our end bone, and the IK solver. Now, because we want to basically find out what rotations are being driven by the inverse kinematics chop when we are set to a blend of completely to IK, we need to actually set our FK-IK blend over to a value of 1 in order to generate the rotational data for IK and not some blend between IK and FK. Because of that, and because I want to make sure that the FK-IK value returns to whatever its value is when we originally start, I first want to store the old FK-IK value, then we can go ahead, set it to a value of 1, do our work, then set back to the original FK-IK value. So we're going to store our old FK-IK value and set to IK, and that's equal to a value of 1. And then later on, we're going to restore original FK-IK value. So we're going to loop each bone, which basically is going to entail doing something for both our start bone and our end bone. I want to find the rotation channels for that bone. which we're going to do by knowing our bone name and knowing the naming convention down on the chop. Since we've renamed everything to always be our bone name : rotate X, rotate Y, rotate Z, we can find the rotation channels for our bone. Once we have those, we can actually set those onto our corresponding FK control. And that's all we need to do for each bone, but we do have another consideration here. This is almost identical to the FK to IK matching that we did back in Technical Rigging 3, but in Technical Rigging 3 we didn't have those manual stretch parameters. Now we do, so we want to make sure that we match the stretch of the IK chain, whether that be an automated stretch because of the IK handle, or whether that be a manual stretch or a combination of both. We want to make sure that our FK matches that stretch. So we do want to make sure that we match FK stretch parameters to current IK stretch ratio. And that's all we need to do in order to match FK over to IK. So again, we're going to set ourselves over to IK, grab the rotation parameters, put them onto our FK controls, then make sure we match up our stretching. So that's all we need to do to match our FK to our IK. Now, in case I want to test this out part way through, I do want to go ahead and make sure that I don't have any indentation. I also want to make sure that my last line of code is not a comment, so I'm just going to print out match FK to IK. Fantastic. So the first thing I want to do is get our button calling this function. So let's jump over to our parameters, down to the match FK to IK button. I want to go ahead and set the callback script language to Python and call on who.pwd, that's us, .hda module, that's going to call into that Python module we just created, .match FK to IK. So if we accept this, and we now click on match FK to IK, we're going to have, as I bring that over from my other monitor, we're going to have match FK to IK printed out, which is exactly what we were expecting, since indeed we were printing that out. Fantastic. So let's bring back up our type properties, and I'm going to go ahead and just drag that to the side for now, and jump back over to our scripts tab, and let's first get the nodes from the asset parameters. So we want to get our IK solver. That's equal to who.pwd, that's our current node. We want a node relative to our node, since we know that that path that we're specifying could be absolute, but it could also be relative. If it's relative, we want to make sure that we're evaluating it relative to ourselves. And that's going to be who.pwd.evalPalm. What parameter are we evaluating? We're evaluating the kinSolver parameter that we just created. So we specify that chop in the kinSolver parameter, we evaluate that, that will give us a path, either relative or absolute. We can then basically send that over to who.pwd.node, and that will evaluate that and turn that actually into a node reference. We can do the same for our start bone. who.pwd.node, who.pwd.evalPalm start bone. And we can do the same for our end bone. So end bone equals who.pwd.node, who.pwd.evalPalm end bone. Fantastic. From there, we want to go ahead and store the old FKIK value and set over to IK. So we can say old FKIK equals who.pwd.evalPalm. And we want to evaluate the FKIK blend parameter, which indeed does exist on this particular node. And let's go ahead and simply print out that old FKIK value. So if we accept this, let's bring back our console. If we click on match FK to IK, it should currently print out a value of 0 along with match FK to IK. Let's clear. We set that to some other value, it will print out that value. We can clear, and if we set that over to a value of 1, it'll print out a value of 1 as well. So let's clear that. Fantastic. Let's go ahead and now set over to a value of 1. Now, because I don't want any keyframes to be caused by this script, so anything that this script changes, I don't want keyframes to be set. I basically want it to change values, but allow the animator to set any keyframes. Now, in this case, we're going to set a value of 1, but later on we're going to set back to our original value. On other occasions in this script, we're actually going to be setting things that will not get set back to what they were originally, and that makes sense. We want to set our FK controls to have certain rotations. That's the whole point of this script, but I'm always going to use set pending as opposed to set, so we don't set a keyframe unless of course we have auto key activated. Instead of setting a keyframe, what we're going to do is simply set a value. If there's a keyframe already on that particular parameter, it will, instead of being a green key on that particular frame, it will be an orange value background saying, yes, we have a pending change, but the animator has to physically actually set a keyframe on that parameter for that change to remain. So we're going to set the FKIK blend to a value of 1, but we have something interesting to do here. IK blend. Now we could just say set pending and pass in a value of 1, but we know this script is going to be called from within an asset, and we know that when an asset is locked, we're going to have certain restrictions. Now, in the current build of Houdini, and I believe this is 9.5.230, in the current build of Houdini, we do have an issue whereby if we were to simply call on set or set pending on a parameter that's inside a locked asset, even if that parameter gets promoted up to the asset level, and we know that FKIK blend in this case is going to be one of those parameters, it will actually throw a permission error. This is something that side effects know about, it's something they're working on. Until then, there is something we can do. What we can say is basically, okay, I want to set the FKIK blend parameter, but instead of setting it directly, find out if this parameter references anyone else. If it does, then find them and continue until we find a parameter that is not referencing anyone else. Otherwise, instead of doing that, we just grab ourselves. So let's say that we weren't referencing someone else, it would just return ourselves. Otherwise, it will return the top end of whoever we're referencing. So we can call on our parameters get referenced palm. That means that when we're inside an asset, when we promote this up to the asset level, it will grab that parameter now at the asset, and it's the asset level parameter which we can set because that's outside of our locked asset. Whereas the parameter itself, even though it's referencing another parameter, if we were to just simply try and set that inside a locked asset, that would cause an error. So we know now we can call on get reference palm. Indeed, I am actually going to do that every time we try and set a parameter. We can call on get reference palm, and that will make sure that we are grabbing the asset level parameter if indeed the asset is in place. Again, this is a known issue, and side effects are working on allowing you to eventually be able to call .palm or .set or .set pending, and that should work from inside a locked asset. Currently, it does not. So once we set that over to a value of 1, that's going to give us IK, and that means we can now loop each bone, take that IK, and basically apply the rotations that are being driven by the inverse kinematics chop onto our FK controls. Before we do that, let's check that that set line is indeed working. So we can call, and currently our value is 0, call on that, and now our value is set to 1, so that's fantastic. So let's loop each bone. Now to do that, we know we only have our start bone and end bone in this case. In technical rigging 3, we had a possibility of having any number of bones in a bone chain. In this case, we're simply setting this up for an arm. We know we only have a start bone and we only have an end bone. So instead of the more complicated loop that we wrote in technical rigging 3, for those of you who joined us in technical rigging 3, in this case I'm going to write a much more simplistic loop, knowing that I only need to loop for the start bone and end bone. So what I'm going to say is for current bone in, and I'm going to create my own tuple called start bone in the first and end bone in the second index. What that means, this is going to return a tuple, and then for every entry into that tuple, we're going to loop saying current bone equal to one of these. So the first time through the loop, current bone will be set equal to start bone, and we'll run through the loop. The next time, current bone will be set equal to end bone, and we'll run through the loop. So we're going to loop through all of the entries into this tuple. That means that instead of having a while loop and we're grabbing parents, it's a lot easier to know that we only want to loop for the start bone and then the end bone. And the first thing we want to do is find the rotation channels for that bone. We also want to set those rotations on the corresponding FK control. So let's find the rotation channels for that bone, and we can do that by using the chop HScript expression. Now I'm going to basically concatenate together different parts of a string to generate that expression. And the first part of the string is going to be the same for all of our bones and also for all of the rotation, different rotation parameters. So what I'm going to do is say that the chop string is equal to chop, and we do want to then start a double quote where we now specify a path to a chop, and we know that that's equal to our iksolver.path. That will give the absolute path to that particular chop. We then want to append onto that a /. From there we want to grab our bone name, our current bone name. So what we can do is we can append to this our current bone.name. We can then append a colon, and from there it's going to be different depending on which parameter we're referencing. Are we referencing rotate X, rotate Y, or rotate Z? So that's going to be our base chop string. And then for rotate X, we're going to say that's equal to who.hscript expression. We wish to evaluate an hscript expression, passing in our chop string and appending onto the end of that rotate X, closing off that reference to the particular chop and channel that we're after, closing off our call to the chop expression, then going ahead closing off our particular string here, and finally closing off our call to our hscript expression. So that's going to close off our call to the hscript who.hscript expression. That will return that rotate X value to us. We can do the same for Y, so I'm going to Control C to copy that, Control V, change that over to rotate Y, Control V, that over to rotate Z. Let's go ahead and do the same for the variables. Fantastic. So now that we've got that in place, I'm going to go ahead and before we do anything else, I'm simply going to print out, and let's print out $f, $f, $f. So 3 floating point values. We can use a modulus to say that we're about to pass a tuple of values to enter into these entries. First one I want to print out is Rx, Ry, and Rz. So this is just a very quick debug to make sure we are getting that data. If we accept this and go ahead and click match FK to IK, we can see we are indeed getting some rotational information. That is fantastic. So we can close that. And then if we bring back up our type properties, we can now apply that to the FK control objects. So let's go ahead and apply this to the FK control. So the first thing we want to do is we want to grab an FK control and set that equal to who.node. We'll take our current bone, the path to the current bone, and we know that it's going to be the exact same path, only with underscore FK control tacked onto the end. Again, if you've renamed your controls, you'll need to either go back and name them such that they have the bone's name underscore FK control, or you'll need to modify how we're referencing those control objects here. So that's current bone dot path plus underscore FK control. So I want to first, before we start setting anything, see is the parameter locked. If the parameter's been locked, we obviously don't want to set it. Trying to set it would cause a permission error. So I'm going to say if not FK control dot palm Rx dot is locked. So if Rx is not locked, then we can go ahead and say FK control dot palm Rx dot get referenced palm dot set pending, and set that to the Rx value that we get back from the chop expression that we called on. We can do the same for our Ry, so dot palm, and in actual fact we can simply copy both of those lines. Let's paste that twice over, and in this case we're saying okay, rotate Y, in which case we want to set rotate Y to the value of rotate Y, and here we want rotate Z, and we want to set rotate Z to the value stored in rotate Z. So with that in place, other than the stretchiness, we should now be matching the rotations on our bones. So we can accept this, and let's go ahead and test this by creating an interesting setup where we can clearly see if this is working. So I'm going to move our bones, and let's add some twist onto those bones. Let's also bring our IK handle up like so. So we don't have any stretch on the bones. You can see that we don't have any IK stretch, but currently if we blend over to FK, we are not matched. But if we say match FK to IK and close, and now blend back, we can see that they are very, very closely matched. They're slightly off. Again, that comes down to an issue that we're having with the way we created the bones in the front view, but they're so close that I'm really not going to worry. No one is ever going to see that. You're never going to see that kind of subtle motion, so that's perfectly fine. I'm very happy with how that's working. So we've got that in place. We do need to match our stretch. Now our stretch is interesting. When we're matching our stretch later, where we say, okay, match the IK stretch to the FK, it's very easy. We simply grab whatever the manual FK stretch parameters were, and we put those into the IK parameters. However, in this case, we want to match the FK to the IK, and the IK stretch could be driven either by the parameter or also by the stretch ratio. But what we can do, we can jump onto our bone and we can evaluate its stretch factor. We know we're set over to IK, and we know that that means our stretch factor parameter, if we accept this just for a second, we know that that stretch factor parameter that exists on the bone is going to return to us the amount of stretch that's being applied to the bone currently based on our IK, but it's ignoring, of course, whether or not we're locked. So this is fantastic. It's going to basically return to us based on IK, upper IK stretch multiplied by the stretch ratio. So it's going to give us that stretch factor that we need. We can then set that onto our FK stretch. That means our stretch for the FK will match the stretch on the IK. So let's bring up our type properties, and let's do that for our two bones. Now you'll notice we are indeed outside of the loop now. I'm going to do this on a bone by bone basis. So I'm going to go ahead and say that the upper bone stretch is equal to start bone dot eval palm. We want to grab the stretch factor parameter, and once we have that parameter, we can now go ahead and say who.pwd.palm, what parameter, that's going to be our upper FK stretch. I want to get the referenced parameter, and I want to set that pending to a value of that upper bone stretch. Let's do the same for our lower bone. So lower bone stretch is equal in this case to end bone.eval palm stretch factor, and then who.pwd.palm lower FK stretch dot get reference palm. So dot get reference palm dot set parameter, dot set pending over to that lower bone stretch parameter. So now that we've got that in place, that will match our stretch. The last thing we need to do, of course, is delete out that print line and set our old FK-IK value back. So we're going to call who.pwd.palm, what palm, the FK-IK blend. I want to get the referenced parameter for that parameter, and I want to set pending our old FK-IK. So that's going to restore that old FK-IK into that parameter. If we accept that, we can now come in, we can see that we're set to FK-IK blend. If we match FK to IK, we return back to that FK-IK blend value of 0. And let's come in and grab, first thing, our FK controls and 0 those out. And then let's grab our IK. I'm going to move my IK down here in this case. Let's blend over to IK so we can see clearly what's happening. And I want to add an upper IK stretch and a lower IK stretch. I want to add some twist. And I also want to pull this such that we extend beyond the limits of that chain. So we now have both manual stretch and automated stretch taking place, and we want to make sure that we match both of those. So let's match our FK to IK, and then we can go ahead and blend back, and we can see that indeed we have matched nicely there. It's very, very slightly off. That comes down to very slight rounding errors, but it's, and the rotation there, again, very, very slightly off. But again, that's because of the way that we've set up that control and the way we created our bones, because we created the bones in the front view, because obviously they weren't perfectly aligned on a plane, and because the IK is driving those bones and creating rotation on the bones that is very slightly off of that plane. That means we're getting very slight X and Z rotations. Of course, we cannot set those rotations. We only want to be able to rotate on Y in this case. Again, it is so very, very subtle that if that was to change from one frame to the next, I wouldn't have any issues with that kind of subtlety. I mean, we go from that on the next frame, that's perfect. I mean, one small movement like that on one frame is really not going to cause anyone any issues. So I'm very much not worried about that very slight movement. So with that, that is going to conclude setting up the matching FK to IK. I do want to go ahead and reset all of this back down to its default parameters. So let's grab our controls and zero those out. And let's also go ahead, grab the IK handle and move that back, and grab the twist control and zero that out as well. So that's going to put us back into our default location. And with that, that is going to conclude matching FK to IK. Thanks a lot.